All right. Good morning, good afternoon, and good evening, everybody, depending on where you're joining us from today. And welcome to the first in what's going to become a series of Mainframe DevOps webcasts. For those of you who may not know me, my name is Len Thompson, and I am Broadcom's Mainframe Division Community Manager. And again, I'd like to welcome you to today's webcast. Before I hand you off to Sujay and we get started, just a couple of things I need to mention real quick. First, you've probably noticed that you are currently on mute. We are recording today's session for those who couldn't join us, so I ask that you please stay on mute throughout the duration of the session. If you have questions along the way, please use the questions box along the right side of your screen, and we'll answer as many of those as we can at the end. The recording of today's session will be posted out in the CA Mainframe DevOps community later today or first thing tomorrow. So if you have colleagues who'd like to share it with, or if you want to listen to it again, that's where you can go to get the link. And the last thing for me is that we're always trying to improve how these sessions work and how valuable they are for you. With that in mind, at the very end of the session, after I close it down, you will be presented with a survey. I'd really appreciate it if you could take a few minutes to give us some feedback on today's session, so we can make the next session even better. And with that out of the way, I'd like to hand things off to Sujay. So take it away, Sujay.
Thank you, Len. I'll share my slides here. Okay, so tell me that you guys can see. Okay, so here we go. So the topic for today is sort of the top 5 tool sets to really accelerate your mainframe development processes that you have in play. My name is Sujay Solomon. Just a little bit about me before we start getting into the details of the webinar itself. I've been in this field for about 10 years doing both product and development work. Went to Penn State, computer engineering, and worked for a few startups as a developer before I started at CA, Broadcom currently. And at CA, I've written a lot of assembler code for ZOS, C as well. And then from there, I kind of moved on to doing more web development and then used common DevOps tools like Jenkins and Gradle, and then for test automation, things like JUnit. And really, I was lucky to be part of teams where the culture of DevOps is just kind of embedded into them. And then from there, I went on to start leading some development teams as a product owner, which is an Agile role, which helps us communicate requirements into a team. And again, I was lucky that I had a couple of teams who were very keen on adopting kind of industry standard DevOps principles and apply that to mainframe software development. From there, we actually came up with some internal tools that really helped us push the needle on doing mainframe DevOps. And we eventually turned that into a product called CA Brightside, and I became the product manager for this product called CA Brightside. And eventually, we actually, CA at that time decided to open source the code for Brightside to become part of the Zoe project. If you've heard, Zoe is an open source project launched by CA, Broadcom, IBM, and Rocket Software. Went live 4 or 5 months ago. So, and I was a founding member.
Hey, Sujay, I'm sorry to interrupt you. We're actually getting quite a bit of background noise from your mic, so could you maybe just bend it a little bit closer to your mouth?
Is this better?
Marginally.
I didn't have any issues before, did I?
Yeah, I think maybe just speak a little bit more loudly. So.
Well, let me try to disconnect from the audio and reconnect the other.
Okay, is this better now?
Yes, much better.
There we go. Yep, yeah, it was picking up my laptop mic. I don't know why that happened. Thank you. Okay, so enough about me, right? You guys are here to learn about how to accelerate your mainframe DevOps, but I just thought I'd give you a little bit of background about myself. So what we've got on the agenda today, we're going to first talk about the personas that are involved in mainframe development. And that's very important because it's not just developers. There's a lot of other folks who are involved in development and the entire process of a life cycle of an application who are very key to making things run smoothly. So let's kind of learn about those personas first. Then we're going to talk about some of the challenges that exist today in mainframe development. And then I'll introduce you guys to a concept called the shift left approach when it comes to testing. It's becoming kind of an industry standard that's really, again, moving that needle along with DevOps today. And then, of course, the meat of the webinar is we'll talk about the top 5 tool sets that we've chosen as being the primary ones that's really going to help you with moving DevOps along. And within those tool sets, we're going to focus on 3 personas. We'll talk about developers first. Obviously, they're the ones who are building value into the platform and continuing to build business value. So we'll focus on them. Then we'll talk about our build and release engineers who are key DevOps roles. And then, of course, putting it all into production and running it and providing value for your end user is your operations engineer, and we'll touch on them as well. And then finally, we'll wrap it up with polls and such. Now, what are we seeing today is, there's almost all of the applications today, they're not running on just one platform. It's really cross-platform today. Going from mobile to there might be a web server running on cloud. There might be a sort of a service bus that's running on an on-prem Linux cloud or a cluster internally. And then from there, a lot of the transaction processing that happens, of course, is very natural to run that on the mainframe. Now, adoption of DevOps and Agile has really picked up when it comes to mobile and cloud. And then, of course, now distributed has also kind of jumped on that, and they've really started to accelerate the time it takes for something to go from coding to delivery is just moving at a really rapid pace. Now, mainframes can't be left behind in that, right? And if there's even one part that is not going at the same speed, then your entire delivery pipeline is just going to be slow. So we want to rectify that. We want to help everybody with really putting mainframe into that same pipeline that is in play with all these other platforms that are so popular today. Okay, so let's meet some of our personas who have an impact on our mainframe application development and delivery. So off to the left here, you've got Michelle, who is a mainframe application developer. Then we have on the DevOps side a couple of roles. A build engineer is usually a person, sometimes they're just part of the development team, but they kind of take on some additional responsibilities of being the primary DevOps person who builds things like continuous integration that's used by the rest of the developers on the team. So that's a build engineer. And then moving off here, Travis is also a DevOps person, but he's more on the release engineering side, where he's taking care of making sure that the deployments in the different stages along the way are happening with the proper approvals in play. And he's not necessarily tied closely to the development team. He's more operating at the enterprise level, and he manages deployments to various stages for multiple applications, regardless of the platform. And then we also have Mindy, who is a enterprise or a line of business cloud or application developer, and she might just be a person who's waiting for Michelle's team to complete working on some transaction updates so she can start using it in her web app. And finally, we have Tyler, who's on the mainframe operations side, who actually helps take the changes that Michelle has built and our DevOps folks have kind of worked through the pipeline. He's the one who actually starts running it in production and he continues with monitoring it as well. So that's our personas for today, and we'll focus on how they play different roles in really making DevOps happen. Now, some of the challenges that we want to focus on today is whether you're a developer. In this case, we're focusing on Michelle. You're involved in DevOps, or you're just part of that pipeline of delivering applications to be in production. you currently, if you're working on the mainframe, you're not really able to use a lot of these tools that most IT and development folks are very prone to using today. So scripting languages like Python, or just even simple shell or bash scripting, continuous integration tools like Jenkins and Bamboo and Circle CI, task runners like Gradle and Gulp, uh, automation testing frameworks like JUnit or Mocha or Chai, uh, popular editors and IDEs like Visual Studio Code or IntelliJ, or even just simple text editors like Sublime, and then linting tools like SonarQube, or deployment tools like Urban Code and Excel Release and CA's continuous delivery automation. It's really tough for mainframers to use a lot of these tools that are out there today. And if you look at cloud platforms or x86 platforms, things like Docker, Git, AWS or Azure, common thing there is they all have a command line interface that's used by multiple folks, developers, IT folks, to start using these tools to kind of make their automation just continuously better. When it comes to the mainframe, that's been lacking so far, and that's where as I mentioned before, there's a tool called Brightside that CA has developed, and it's also part of the Zoe open source project, which offers a consolidated command line interface, a client-side CLI, with a set of core commands to the mainframe. So the core commands will let you interact with various things on ZOS. So things like console commands, datasets, jobs, TSO, and so on and so forth. So this is really, it helps with connecting to the operating system and interacting with it in a modern way from all of these tools that you see here. In addition to that, there's also a rich set of plugins for the command line interface that interact with things like DB2 or Kix on the mainframe. And on the Broadcom side, we have a few plugins for tools like Endeavor, FileMaster Plus, and OpsMVS. And I'm proud to say here that DevOps.com is really, it's one of the largest collection of DevOps content on the web, and they host a lot of webinars and really help with educating folks on the modern trends in DevOps. In 2018, at the end of the year, they always do a set of recognitions of products, and they announced that CA Brightside was actually the most innovative DevOps solution that was released in the year 2018. So we're proud to share that here. Now, let's move on from the challenges there. One of the solutions we're proposing is a client-side CLI that helps you with connecting and interfacing with mainframe services. Now, moving the needle along, shift left. What is shift left approach, and what is shift left testing? So shift left testing, and this is just from some simple Wikipedia here, is it's really an approach where software testing and system testing is performed earlier in the life cycle, and that's why it's called shifted left. So you're just moving those testing actions further left on the project timeline. And the reason that that's done is I'd like to focus on the chart on the left here first. Is without shift left in play, let's look at these three things here on this chart. So as you're coding, that's typically when majority of the defects are injected. As people are developing things, and there's really no software that's going to be defect-free as it's being written. So you can see here that 85% of defects are actually introduced pretty early in the cycle during coding. Moving on, at unit testing, there's some that are found. At functional testing, there's more defects that are injected. At system test, and more injected. And of course, at release time, it's really it's out, and there's really no chance for defects to be injected at that time unless there's maintenance going on. Now, the interesting thing here is in this scheme where you're not shift lefted, your defects are being found, not barely anything as things are being coded. When unit testing is going on, some of it is found. And then when functional testing is going on, there's about 10 times as much as what's found during the coding phase. And then at system test phase, 40 times. And then if you after the release, it drops down below, but there's still a decent amount of defects that are found after it's in production as well. Now, let's take a look at the red line here. So that indicates the cost of actually repairing these defects in this timeline. So if we take the cost here, if you're looking at finding the defect and fixing it while it's being coded, that's a unit of 1. And it just continues to grow and grow. And if you find the defect after it's out in production, you're at 640 times the cost of if it was found as you were coding it. Now let's bring a shift lefted approach into play here, and you can see here that the first thing that happens actually is the number of defects that are introduced itself drops from a large amount here to a fairly smaller amount here, and that's because they're continuously testing things earlier in the process of developing software, and that allows the developers to sort of always think about whether they're introducing defects. Now, there is, with a shift-lefted approach where you're doing all your testing early in the process, you're finding a lot more of these defects early on. You can see here that the orange curve is really maxed out at the coding phase, and then continues to drop down through the course of these various stages of testing. And then finally, once it's been released, there's a marked difference here between the amount of defects that are found when you're shift lefted versus if you're not. So imagine the cost savings that are at play here as you're finding defects earlier on. And it's really, this is being adopted heavily even here internally at Broadcom, where we obviously do a lot of software development, and we're encouraging initiative, we call it actually engineering excellence, and we're really encouraging and empowering our teams to start doing a lot of this testing earlier on in the process before we start releasing our products. Now, how do you actually enable such an approach, right? The shift left approach. It's really, from my own experience of us going through this process at CA Broadcom, we actually went through our own Agile transformation, which started 2011 or so, and I was part of development teams before and after. And for me, I view it as really 50-50. Half of it is essentially a cultural shift that needs to happen. And then the second half, of course, is the tooling that's available for you. So obviously, we're going to be talking more about the tool stack in this webinar, but I'd like to touch a little bit on the cultural shift that also needs to happen. So educating cross-platform teams on the importance of testing early and often is very, very essential. So kind of what I shared in the previous slide, top-down approaches are tough to implement, because if your teams are not bought into the value of testing early, then they're really not going to do it with their whole heart. So really, they need to understand the value of testing early. The other thing I've noticed is that there needs to be sort of a change in the mindset of worrying about system resources being consumed by shift-lefted testing. And I've heard, especially on the mainframe side, hey, if I test all these things early on, I'm burning a lot of MIPS for that. But there's options for that today. In ZOSMF, you can provision things in your dev environment. There's containerized options. There's even things such as ZDNT, which allow you to virtualize the OS and run your tests there. So technically, there's no reason to say that we're worried about a lot of MIPS being burnt by these tests. So that mindset really needs to change, and here's where I'd say the distributed side and the cloud side really have an upper hand there, and we've got to work on changing that mindset on the mainframe side. Now, the next one I'd say is educating the teams on adopting open source frameworks and enabling this sort of a cross-platform DevOps initiative. You really don't want to build everything from scratch. People have done DevOps, and then it's running many large organizations, enterprise software delivery systems, and a lot of them are using open source software. Reinventing the wheel is probably not wise. And I'll talk a little bit more even further about the advantages of adopting open source in implementing cross-platform DevOps. Finally, something else that I've heard a lot of is mainframes have been around for a long time, and there's been a lot of automation that's already built up in traditional scripting languages like Rex or batch jobs and JCL and such. Mainframe teams really need to be empowered to start reusing that same automation that they have built up and integrate it easily with modern DevOps methodology and tooling. So they shouldn't have to throw that all away and rewrite things, right? What's the point in doing that? So they need to be empowered to just think about how can you use the existing automation but tie it in with modern DevOps methodologies. All right, so moving over to the tool stack side, we got to identify some common tools to be used for mainframe and distributed software development, and then establish some standards on actually integrating these applications, regardless of what platform they're running on, into an enterprise-wide tool stack. So there's a kind of a homogeneous set of DevOps tools that are at play, and this is important because one of the things I've heard from enterprise architects who are involved in DevOps transformations is there's a key to people working on applications in different platforms being able to speak the same language when it comes to DevOps. And that can really only happen if there's some commonality in the tools that are used to actually implement DevOps across platforms. A key to doing that is identifying bridge tools that actually help with tying mainframe's traditional services and making them kind of fit naturally into your common tool stack that you've chosen for DevOps. And this rings true with a lot of organizations that I work with, where they come to me and they say, hey, we've already implemented a lot of our DevOps practices for our cloud workload or our on-prem Linux workload. Help us with just pulling mainframe into that same stack rather than kind of reinventing the wheel for mainframe. And that's again, I'd say that's where a tool like Brightside really comes into play and helps out. So we'll be talking about that as well. All right, so now what you guys have been waiting for all this while, we're going to start talking about the top 5 tool sets. Now, just to give you a bit of background, the criteria with which we chose these 5 tool sets is we really wanted to focus on tools that are going to enable dev teams to start shifting left. And then, of course, on anything that can help with fostering that culture of automation and DevOps bottom up, rather than it being an initiative that's pushed top down. We focused on that as well. We also wanted to make sure that there's a chance for cross-platform CI/CD to use homogeneous tools. And then finally, this is kind of the nirvana here, is paving the way for sort of hybrid cross-platform development teams to emerge naturally. I was at the Think conference this year and last year, and one of the large banks in the US and North America was there, and they shared their experience where they took a couple of mainframers and they put them on working on the distributed side of things, and they took some developers from the distributed side and they worked on mainframe for just a couple of months, and skills transferred over. They got used to working on different platforms, and then eventually they actually merged those teams and they started working on applications, full stack applications, all the way from cloud down to mainframe together, and they just saw that these teams' productivity just completely skyrocket. So hopefully that's something that we can all work towards, where we're not bound by what platform we work on. So those are the criteria that we chose to really pinpoint which tool sets come into play here. Now, I'm going to play a little bit of a game here. At the end of the webinar, as Len mentioned earlier, we're going to be polling you on sort of for you to choose your top tool set out of the 5 that we're going to be sharing with you today in accelerating mainframe development. I have my own prediction on what's going to win out, but we'll kind of test my knowledge on how well I know my own audience here. And then a bonus here is your poll responses are actually going to determine what our next webinar topic will be, as this is actually a series of webinars that we're starting on accelerating mainframe DevOps. Okay, so with the tools, we're going to go by some of the personas that are involved. So we're going to start with developers because they're the ones building code into our platform, right? And I've got a slide up here that talks about the entire process of delivery of software, from all the way from planning to operations, and includes the development as well. Development kind of sits here right before and part of the continuous integration cycle, and our Michelle, our mainframe developer, is really key there. When it comes to development, though, but it's not just your developers, right? You have secondary personas. Our build engineer, who we talked about, who's building continuous integration, maybe our tools administrators, who are maybe maintaining things like GitHub or Endeavor on the mainframe and such. But at a very basic level, developers are doing 3 things. They want to keep writing code to provide value, build that code, so doing things like compilations and such. Then they want to test the code that they wrote. As a developer, that's 5 years, that's probably what I did day in, day out. Where we are today with writing code on the mainframe, you're typically using ISPF or Eclipse IDE, and then when it comes to accessing the source code, you're probably on Endeavor, which is leading SCM on the mainframe, or maybe you're just on plain old data sets, or maybe some other SCM on the mainframe. Where this really needs to move to is developers are going to have to start accessing that source code using more modern methodologies like Git integrated with Endeavor on the mainframe, or maybe whatever SCM they're using, Brightside can actually help access the code that's living on that SCM on the mainframe. And with that, they can then start using their IDE of choice. They're not tied to just Eclipse. A lot of developers today like using a variety of IDEs and editors. Now with build, again, an SCM like Endeavor on the mainframe is typically where the build is performed, or sometimes they just run jobs on the mainframe. And then of course, through IDEs, there's integration to perform build as well in the existing Eclipse interfaces that are there. But moving that forward, again, the build logic is going to remain on the mainframe on tools like Endeavor, but to make it more accessible and flexible for developers, we need to introduce things like task runners and build tools that are used by most developers that are out there today. Finally, with testing code, a lot of it is done today using maybe for unit testing, there's ZUnit. Some of the system-oriented testing is done in languages like Rex, but majority of the testing is just done manually. Or I've even heard cases where developers just push that off to the next stage, to maybe the QA stage, and they just rely on them to do the testing. Now, where we want to move this is obviously keep unit testing in play. So frameworks like ZUnit, or actually IBM has something new called the Z Open testing framework that even lets you mock kicks and such for unit testing. So that's an awesome framework for unit testing. And then for things like system and integration testing, other open testing frameworks that are out there. So I'll be talking about particular ones later, using code analysis, static analysis tools like SonarQube, and then injecting test data from tools like CA Test Data Management, either artificial test data or mass data from a production library. That's common to do on the distributed side, and we've got to encourage developers to have more control in being able to use such tools for mainframe testing as well. Now, simplifying all of that, and looking at our first tool set here is really focused on developers being able to access source code for mainframe applications. And I've got that branched into two sections here. On your developer's workstation, you ideally want some Git-driven operations for the developers, whether that's through enterprise repositories like GitHub, Bitbucket, or GitLab, and then interacting on the mainframe with Endeavor as the SCM. That allows the developers to have their freedom when it comes to accessing the source code using an interface that they love, which is Git today. But all of the source code, your processes that are in play on the mainframe continue to remain in an SCM like Endeavor. Now, another approach, if you're not on Endeavor, if you're not on some other SCM on the mainframe, of course, Brightside can help with that, along with modern scripting languages like Python and Bash and Shell. That can help developers with accessing the source code on the mainframe on other SCMs. Of course, not as ideal as using Git, but this is still a step ahead and much further ahead than having to log into ISPF or being tied to only being able to use an Eclipse integrated buttons and such to access the source code. Now, source, in terms of the choices that we made there, what is the reasoning behind that? And this is actually, these are charts taken directly from Stack Overflow's developer survey that was done in 2018. And you can see here that close to 87% of developers in the world actually are using Git today. And that's just so popular, and it's becoming the de facto standard for accessing source code. So most people coming out of college are completely comfortable with using something like Git to access source code. Now, whether you're using Git or maybe using Brightside and in combination with other SCMs and scripting languages to access source code on the mainframe, what that allows you to do now is you're not tied to a certain developer environment. Again, Stack Overflow, the survey here suggests that 35% of developers today are using an editor called Visual Studio Code. And you can see here that something like Eclipse is actually much further down the list here, as it's kind of losing in popularity here. And some of these lightweight editors are actually being used much more than some heavyweight ones like IntelliJ and Eclipse. So again, opening up the code using something like Git or Brightside in combination with Python and shell scripts gives your developers the flexibility and helps for them to doing with when they're merging code and such, they're not restricted by what's on the mainframe alone. Now, the next thing that I want to talk about, and let me, some of my slides aren't showing up properly here. Let's see. Okay, that's a little bit better. So again, we're going to continue to focus on developer or Michelle persona here. Another thing to focus on is task runners, or sometimes they're called build tools. Brightside, in combination with tools like Gulp or NPM scripts or Maven that you might have heard of that Java developers are very fond of, these tools can be used to simplify and abstract common tasks that developers have to do as part of coding, building, and testing their code. So, common actions that you might do on the mainframe, you might want to compile your code or link edit your code. You might want to copy the results, so the load libraries from one location to another. Maybe you want to provision test environments. Maybe you want to deploy to a test kicks environment, or maybe you worked on a batch program and you just want to run that batch program very quickly as you're making code changes. And then you want to, before you even run any tests, you just want to validate your test environment to see if it's all in place. And then, of course, you want to also run your automated tests that you've written to test your application that you've built. These task runners come into play and really make the developers' lives a lot simpler there. And I'll share why here. So these common build tasks can be done in multiple ways. It can be manual, or on the mainframe you can go and submit jobs, or you can go to ISPF tools and start interacting with SCMs directly there to do generates or do it from Eclipse. But a common thing that developers do today is they take control all over that process that helps them with building and testing their code using some of these common tools like Gulp and NPM scripts and such. What this offers is it allows you to organize your tasks that are common as a developer to share that with others, and it also provides for easier readability. Think about how this is structured here, and I'm showing this is actually a plugin in VS Code that helps you organize your tasks if you built them in Gulp, and it really helps you see them in a hierarchical fashion. Tough to do on typical green screens, really. Task runners also give developers the freedom to build automation quickly for their own use. They're not bound by administrators or such, and they can also easily integrate with popular CI/CD tools like Jenkins or Circle CI and such that are popular today. And as shown here, task runners also integrate nicely with IDEs, so they can graphically see, hey, I can just go and double click on a task here, and that's going to go and compile my code. Double click on another task here, that's going to go and deploy my code into Kix. So common actions that they need to do before they build or test their code. And then I'd like to share, my choice here is really between Gulp or NPM scripts today. Both of them are JavaScript based. And, with the explosion of Node.js and JavaScript today, writing your scripts in something like JavaScript really helps you with taking advantage of a lot of open source libraries that are out there when it comes to parsing or generating reports from some of these tasks. Toolset number 3, as again, continuing to focus on developers here, I share that there's a lot of open frameworks like Chai or Mocha.js, which kind of focus on system and integration testing here. Same with Jest, and those are both JavaScript-based testing frameworks. There's also Robot, which is a Python-based testing framework. Or if you're looking more into load testing, performance testing, there's open source frameworks such as JMeter. Brightside, in combination with a lot of these testing frameworks, is going to help you perform a variety of actions on the mainframe as part of your suite of automated tests. So now you're not restricted on the mainframe to only being able to automate, say, your unit testing. Really, the opportunity is there to start automating your system tests, your integration tests, your load tests, your performance tests to a much greater degree, using the same frameworks that are probably used by the cloud side of your application or your mobile side of your application. And this is where, I was saying earlier, it's important to kind of start relying on a homogeneous set of tools across the different platforms that you have in play with your applications. And with the help of Brightside and these open testing frameworks, here's just a small sample of what is possible. You can automate the testing of your batch applications. So things like submitting jobs or even scheduling jobs into a scheduler like CA7 or ESP, verifying the output from that batch application once it's been submitted. You can get the spool data sets downloaded and parse it and verify it. Or if you're testing Kix transactions, you can invoke them. You can verify that that transaction ID that came through Kix is actually doing data lookups, database lookups in DB2. And then, when it comes to things like performance testing, one of the things that I've heard from a lot of folks that are focused on load and performance testing, hey, mainframe, I'm able to invoke the tests, but the things that happen on the platform are kind of a black box for my load tester. There's no information on things like CPU usage as the tests are running, or I/O that's going on, the amount of memory that's being consumed by a particular process, or I guess on the mainframe side, address space. A lot of these performance performance testing frameworks that are out there, they thrive on having these metrics from the system. So CPU and IO metrics as you're maybe concurrently hitting your Kix transactions hundreds of times, and you want to monitor and feed the type of CPU and IO metrics that are being generated as part of those tests. Now, all of that is possible with the combination of Brightside and some of these testing frameworks that are out there. Now, why should you consider using automated testing frameworks? So as I mentioned before, there's different levels of testing, right? When it comes to automated testing, there's unit testing, integration and system testing, load and performance testing. And a key to using automated testing frameworks is you're now going to start using popular scripting languages, which really makes it easier for newer developers to quickly build up these automated tests. So like I shared before, JavaScript or Python are common languages used in these testing frameworks. From a maintenance cost perspective, I'm going to share here Mocha.js, I said, is open source. And you can see here that it's been forked close to 2,400 times. You've got 400 plus contributors who are continuing to maintain this framework. There's millions and millions of developers in the world who are actually users of this framework, using it across various platforms. And it provides a lot of common libraries, things like assertion. So, hey, here's what the expected output was, and I'm going to match it up with what actually came as a result of my tests. You don't have to build logic for that. These frameworks come with code and functions that help you do such things, these classes that are just built in there. Report generation after the test is done is usually built into these frameworks. Watching the code as you're changing it and dynamically building the tests and running them. Or if a test runs into problems and you need some sort of an asynchronous timeout as the tests are being run. And those are just a few examples of common functions that are provided by these frameworks that you personally don't have to build from the ground up and maintain. So that's really where the benefit comes in here, is you're using libraries that are trusted by millions of developers. They maintain it, and you don't have to introduce all that logic yourself. Another key aspect, and quite an important one, is this final one, is of using automated testing frameworks, is the integration that they have with CI/CD tools like Jenkins and CircleCI. You're able to easily call these automated tests from continuous integration, as well as take the reports that are generated by them and store them in something like Jenkins, and maybe even push them out into your test repositories at an enterprise level, so that there's full transparency and people being able to see the quality of tests that are being written and application being delivered. All right, so we had 3 sets of tools there for developers, but as I mentioned before, developers are not the only ones who are involved with the process of delivering software, right? You have folks like our build and release engineers as well. And typically a build engineer is involved earlier in the process of development, so at the continuous integration level. And I've got this kind of shaded less granular at the end, because with each organization, it's really different. Some folks tend to save things like performance testing for later in the game, so when it may be closer to continuous deployment. Some tend to do that, the ones that are really shift lefted heavily, they have that as part of their continuous integration as well. Now, but that's the role of a build engineer. What do they typically do? They're collecting their automation scripts, they're writing maybe new process automation scripts, they're integrating this process into a CI orchestrator, and then finally delivering these artifacts into the CD orchestrator as well, which and we'll meet that persona next as a release engineer. So today, they're likely doing this in Endeavor, or doing it even outside of Endeavor manually without using the Endeavor processors. In the future, they're still going to keep using Endeavor, right? The processors are there. There's a lot of logic in there that's been there for many years. But then they're also going to start using some Git repositories where they're probably storing some of their modern automation scripts as well. They're going to be writing these scripts today in just maybe in languages like Rex or Batch. That needs to also move into modern languages like Python or even something simple like shell scripts as well. And then when it comes to continuous integration, today there's been a lot of process built in to Endeavor, and it's really awesome the level of automation folks have built in Endeavor over the course of years. But of course, some are also doing it purely in a manual fashion. Now, in a future where your developers are using task runners and build tools, continuous integration orchestrators really come into play. So things like Jenkins are valuable tools for build engineers to introduce transparency and trust into the development process, and we'll talk about that a little bit later. Finally, delivering these artifacts to the continuous delivery orchestrators today, they're likely again in Endeavor or in just data sets even outside of Endeavor if you're using other SCMs. There's sometimes no reason to move these binary artifacts outside of Endeavor. It's perfectly fine to access it from there. But I have heard some where they want to standardize where these artifacts want to be stored, maybe in binary repository managers like Artifactory and such. So that might also come into play for our build engineers. Now, we're going to cover two of them at the same time. So a release engineer is also involved in DevOps, but more so on kind of the further right in the pipeline and in the timeline here, where they're more focused on the performance testing, the security testing aspect of it, and maybe less so on just the unit testing and build side of things. They rely on our build engineers to provide the artifacts to them. So again, today they're likely collecting the artifacts in Endeavor. They may also start using these other binary repository managers. From a release pipeline perspective, it could be manual or built into Endeavor. They'll continue to use Endeavor for the staging process, but they may also introduce new release orchestration tools that we'll talk about. And then finally, deployment platforms. Obviously, they're using Mainframe today, and they're going to continue to use Mainframe, but they'll likely do it in more of a cloud-like fashion from an interaction perspective. So our two folks here are Ravi and Travis, build engineer and release engineers. Simplifying all of this, they're going to be using Brightside in combination with popular CI/CD tools, Jenkins, Bamboo on the CI side, or on the continuous delivery side, Urban Code or continuous delivery automation from some CA Broadcom. They're going to automate some common tasks on the mainframe here. You know, if an event happens in a mainframe SCM like Endeavor, say new code was moved up to a different stage, that's going to trigger continuous integration automatically. Then CI will pick it up from there, perform a build, perform the deployment from Jenkins, and then also run your automated tests. Once those tests pass, they can build things like approvals for packages into that pipeline so that it's all transparent and documented as part of your continuous integration pipeline. You hand it off to continuous delivery, you maybe promote and deploy to the next stage, and then of course deploying it and monitoring it and activating it in production also comes into play with some of these continuous delivery orchestrators as well. So these are typical actions that are performed by Ravi and Travis as part of CI/CD. Now, why are we pushing for this? Trust is really the objective here. Is, you know, I've been part of dev teams where somebody said, hey, I tested all this, I'm going to give you the green signal, go ahead and move it into production. But, you know, maybe they've been wrong a couple of times. Now, where continuous integration comes into play is there's really no room for human error at that point. Everything is traceable. You can see who performed the build, where the tests ran, what the results of those tests were at what time, and that's completely transparent and available to everybody. Second reason is, I like to say that developers inherently are lazy, but that's good because the fact that we're lazy, it leads us to build more and more automation. And here's a perfect scenario where, if a team has to spend 2 hours every week with moving things across different stages, to them, that's wasted time. So if they build that into continuous integration and delivery, they are saving time and that makes them happy. And finally, operations. They play a key role. Tyler is involved in rolling out software upgrades as well as application updates as well. So when it comes to software, things like CICS running on the mainframe, that needs to be updated. Maintenance needs to be placed on that. Application changes happen all the time. Transaction code is changed. Maybe new APIs are introduced. Today, most of that is done manually. However, there are new tooling like infrastructure orchestrators and infrastructure as code that can really help with moving this side of things more towards a DevOps world. So configuration management and infrastructure orchestration is our tool set number 5. And this is mostly targeting our mainframe operations folks, where with tools like Ansible or Salt Stack that you might have heard of in combination with Brightside's command line interface, it's going to really help with on the mainframe side, a few tasks here that are typically performed by our operations folks. So they can centralize their master and gold copies of software or applications. And then they can make updates to that master copy and then use these tools to kind of automate watching those applications and software changes happening to them. And as changes are made to them, these tools can help with automating new resources on the mainframe. And then finally, automating the deployment of software changes, whether that's vendor software, native ZOS software, or deploying your application changes as well. And this is really where the concept of infrastructure as code comes into play. And, for example, it can really help with spinning up an entire new infrastructure by just running a script. And once you take infrastructure orchestration and you put it into code, you get the advantages there of version control, and you can easily see a history of the configurations you've had. It's going to also be faster, and there's going to be consistency established in the configuration. So every time, it's a process that can be repeated because it's just code, and you can see that clearly. It minimizes risk, saves a lot of expenses, and in a shift-lefted world, developers should be able to communicate with these operations folks to maybe even take advantage of the same infrastructure as code to provision their test environment even during development. And you can see here, infrastructure as code really helps with creating all these environments for you on demand in a homogeneous fashion. So that's our tool set number 5, is configuration management and infrastructure orchestration using tools like Ansible. Now, I know that was a lot to cover, but in summary, we talked about 5 tool sets here for developers to access source on the mainframe. Task runners are used to abstract common things that they do, like compilations or deployments for testing purposes. Automated testing frameworks are used for automating your application system integration tests, load tests, performance tests. And then your DevOps folks, right, your build and release engineers are going to be using CI/CD tools. And then finally, configuration management and infrastructure orchestration tools for your operations side of things. That wraps up our top 5 tool sets for mainframe. And with that, I'm going to hand it over to Len, and we're going to invoke a poll here on your ranking of the top 5 tool sets. So we'll give that about 30 seconds there for you guys to answer that.
Just another couple seconds, folks. All right, I'm gonna go ahead and close it.
Okay, so I'm seeing the results up here, and you know, I said that I was gonna predict where this was gonna go, and you know what? You guys actually proved me wrong. My guess was CI/CD, and it looks like source access actually has won out. So you're giving us work for the next webinar. So as I mentioned, your poll answers are going to drive the topic for the next webinar. And I just want to share here that our next webinar is going to be on April 9th. And here's the link that we'll share it up on the screen here. We'll also share it offline after the webinar is done. Then I'd also like to invite you to visit ca.com/Brightside. There's a few things that are available for you there. There's a community edition of Brightside, which is a free download. You can start download it, set it up, and feel free to start using it. There's also a lot of sample scripts and code available at the resources section on that page for some of the automation that I was talking about. There's also a very informative white paper on an experiment that we did here internally on CI/CD, where we merged CI/CD for the distributed side as well as the mainframe side into one pipeline. And then the set of webinars that we've been doing, we've recorded them and placed them there as well. So with the minute that I've got left, I'd like to ask Len if there's any questions that have come through that we can have a chance to answer here.
Yeah, just hold on one second. There's one that came in. Let me pull it up so I can read it. All right. I get what you're saying about using testing frameworks, but we have many older mainframe applications that get modified very frequently. Is the effort worth the return on these applications? If not, do you anticipate always having a certain amount of manual testing that will be required?
Thank you. That's a great question, and you know, this is always a battle that's fought between you know, the folks leading teams in agile teams and the developers themselves. Developers will scream and yell that they always want to build automated tests because you know the value of building those tests up front, or even if you have older applications and you have to play a lot of catch up in building those tests, it's gonna pay dividends down the line, because you can imagine not only is the cost of perhaps finding a bug in production, as I shared earlier, fixing that later in the cycle is very expensive, but even more than that, just think about the number of times that developers have to go and manually test these things for them to gain confidence in the code changes they're making. So it's gonna, I would say, spending cycles with automating existing applications is really, it's well worth the time. And the way I would do it is, you know, this is what we did at Broadcom, is we always, we followed Agile, and every sprint we dedicated about 20% of our time to play catch up with automating tests. So we understand that you can't just spend your whole time automating tests, but I'd say dedicate a small portion of your sprints, 15 to 20%, save that time for catching up with automated tests. Okay, I'll hand it back to you, Len.
All right. So folks, we are just past the top of the hour, so we're going to go ahead and wrap up. If you have any further questions, please feel free to go out and ask them in the communities, and we'll make sure that we get your follow-up email sent out with the replay link and also the link to the next session. You should get that email tomorrow. So have a great day, and we'll talk to you next time, everybody.